Here's problem 31-2. A flat coil wire consisting of 20 turns, each with an area of 50 square centimeters, is positioned perpendicularly to a uniform magnetic field that increases its magnitude at a constant rate from 2 Tesla to 6 Tesla in 2 seconds. If the coil has a total resistance of 0.4 ohms, what is the magnitude of the induced current? Here's a coil, flat coil. Number of turns is 20. And we're told that the area of this coil is 50 square centimeters. That's going to be 50 times 10 to the minus 4 square meters. And we have a magnetic field going through it, so I'm going to just indicate that going into this coil, and our final magnetic field is 6 Tesla. Our initial magnetic field is 2 Tesla. So our change in magnetic field, 6 minus 2, or 4 Tesla. And it's going to do it in 2 seconds. Alright. Well, we know from Faraday's law that the magnitude of the average EMF is going to equal the number of turns times the change in flux over the change in time. And the flux would be field times the area cosine, in this case 0 degrees. So this is going to be number of turns times the change in field times area over the change in time, but the area is constant. So this is going to be number of turns times the area, change in field per change in time. That's going to be equal to 20 turns times an area of 50 times 10 to the minus 4 meters squared. Our change in field is 4 Tesla, and we're going to do it in 2 seconds. This is equal to 0.2 volts. That's our EMF. We want to find the current. Current is going to equal that voltage, EMF, divided by the resistance. 0.2 volts divided by 0.4 ohms is going to be 0.5 amps. So the value of our current in this circuit as we increase the magnetic field is going to be 0.5 amps. Now as I'm looking at it, we would have a flux increasing to the page. Nature's response would be to create a flux out of the page by the right-hand rule, which means that this, as I've drawn it, this current would actually flow counterclockwise by the right-hand rule in order to create a magnetic field in the opposite direction out of the page.